By remembering these 5 tricks, we can solve the problems easily in our Neet or JEE advanced examinations. These are very important. For example, if you see 5 moles of A reacts with 20 moles of B, calculate the number of moles of C formed. Here the reaction is given as A plus 2B gives rise to C. Here what is the first trick? Number of moles of reactants and products given in the question. Here first step is we have to write number of moles of reactants and products. Here number of moles given is 5 moles of A. Here number of moles is 5 moles of A. B, that means 2 moles of B. Here 20 moles of B is given to form some product. C is given. Then number of moles of C we don't know. This is the first step covered. First trick. Second trick is write the stoichiometric coefficient. The number before A or B or C is nothing but a stoichiometric coefficient. We have already learned. The number before A is 1. The number before B is 2. The number before C is 1. That means stoichiometric coefficient are also over. Third trick is divide 1 by 2. That means third trick is divide 1 by 2 here. This is the third trick. That means number of moles by stoichiometric coefficient. Here for A, number of moles is 5, stoichiometric coefficient is 1. That means 5 by 1. Here again, number of moles of B, that means 20 by stoichiometric coefficient is 2. Here the number of moles is we don't know. That means NC, stoichiometric coefficient is 1. Here 5 by 1 is nothing but 5. 20 by 2 is nothing but 10. That means 5 moles of A and 10 moles of B is reacted. For 5 moles of A reacts with 10 moles of B to give some product C. Next, fourth step is the reactant which has minimum of this ratio is limiting reagent. By observing this 5 moles of A, that means this is Na and this is Nb. By observing this 5 moles and 10 moles, that means here the reactant A are having 5 moles, reactant B is having 10 moles. By observing this, the minimum is 5. That means here the limiting reagent is Na. That means 5. The limiting reagent is 5. Next, fifth step is we know mole analysis. Mole analysis. How to analyze mole? We will see. Here for analyzing mole analysis, here we have to write for A reactant A Na by its stoichiometric coefficient is 1 is equal to, for mole B Nb its stoichiometric coefficient is 2 is equal to, for mole C Nc the stoichiometric coefficient is 1. That means here Na is the limiting reagent. We already know in the fourth trick. By using this limiting reagent only, we have to find out the product Nc. By using these two combinations only, we have to find out the product C. Now we will see. Na is nothing but 5 by 1. Here Nc is nothing but Nc by 1. That means Nc is equal to 5. The number of moles of C is nothing but 5. Here the answer was got by using this trick. Remember once, the first trick is write the number of moles of reactants and products. Second trick is write the stoichiometric coefficient. Third trick is divide 1 by 2. That means number of moles by stoichiometric coefficient. Fourth trick is the reactant which has minimum of this ratio is limiting reagent. Fifth trick is mole analysis. By using the limiting reagent only, we have to, this one is mole, this one is mole. That means number of moles of A and number of moles of C. We can analyze these two. Then we get NC, number of moles of C. Using these tricks only, we can solve another type of example. First, say example problem. A plus B gives rise to A to B3. Initially, 6 moles of A and 20 moles of B are taken after the reaction. Calculate its limiting reagent moles of A, B, A to B3. Initially, we have to write equation once. Here equation is A plus B gives rise to A to B3. Here 2 A's are there, that means we have to write 2. B3 B's are there, we have to write 3 here. This is the balanced equation. Okay, here the first trick is, as we know, write down the number of moles of reactants and products. Here initially 6 moles of A, that means 6 moles of A, 20 moles of B, and it is, we don't know, A to B3. Second trick is write down the stoichiometric coefficient. Here the number before A and the number before B and the number before A to B3 is nothing but stoichiometric coefficient. 2 here for B, 3 for A to B3, 1. These are the stoichiometric coefficient. For third step, divide 1 by 2. That means 6 by 2 is nothing but 3. 20 by 3 is nothing but some 6.6. Here, leave this. Fourth trick is limiting reagent. By observing these two, 3 and 6.6, which one is lower in number? 3 is the lower in number. By observing 3 and 6.6, 3 is the, that means number of moles of air consumed. This is known as limiting reagent. Next trick is mole-mole analysis. We have to write the mole-mole analysis for reactants and products first. Write like this. Na, number of moles of A, by stoichiometric coefficient is 2. Nb, number of moles of B, by stoichiometric coefficient is 3. Na to B3, number of moles of A to B3 by stoichiometric coefficient is 1. Now this is the limiting reagent. A is the limiting reagent. That's why we have to analyze the mole-mole analysis by using limiting reagent with the product. Then we have to write like this. Then we have to compare or analysis for these two moles. Na by 2 is equal to Na2B3 by 1. Na is nothing but 6 by 2 is nothing but 3. That means Na2B3 is nothing but 3. That means number of moles of products are formed is 3 here. Next, then we will get second. First one is limiting reagent. We know number of moles of A is the limiting reagent. We know number of moles of A is the limiting reagent, means here Na is nothing but 3. This is the limiting reagent. Whole A is consumed. That means Na is 3. Here, as we got from this, Na2B3 is 3 only. Next, we have to see Nb. That means we have to compare like this. Nb by 3 and Na by 2. If we compare this, Na by 2 is equal to Nb by 3. Na by 2 is nothing but 6 by 2 is equal to Nb by 3. Here Nb is equal to 9. That means here number of moles of A, that means 3 moles of A is reacted with 9 moles of B to give again 3 moles of Na2B3. This is the, that means here 9 moles are consumed, means how many moles of B are left? Number of moles of B left is, we know already, 20 moles minus 9 moles here consumed. That means 11 moles of B is left. I hope this exercise is used for your competitive exams. If you like this, please subscribe.